In section 6.2, we are going to now begin to solve some linear equations. And to do this, we basically want to get this variable or a letter all by itself on one side of the equation. And to do that, we are going to use what we just did above here using our opposite operations to both sides of an equation to get this variable on its own. So looking at example 1, we have x minus 3 equals 1. Now to get this x all alone, basically what we're going to do to get this negative 3 equal to 0, we're going to add 3, and then whatever we do to one side, we do to the other. So we get this negative 3 and positive 3 cancels out. We get x equals, and then 1 plus 3 equals 4, and that is our answer. And right, if we think about this actually makes sense. If we say x equals 4, if we're to plug in x here, we could say 4 minus 3 equals 1. And does 4 minus 3 equal 1? Well, yeah, 4 minus 3 is 1, so 1 equals 1. So this is true, and this is what we're doing here. We're basically asking the question, what minus 3 equals 1 when we do this? So looking at example 2, we have x minus 7 equals 3. And to get this x on its own, we're going to add that 7 to both sides. So we're going to get this negative 7, positive 7 cancels. So we're just left with x. And then 3 plus 7 is 10. Looking at example 3, we have x plus 1 equals 2. I encourage you to pause the video and try this on your own and see when you have work through it. Let's go through it. So to get this positive 1 equal to 0, to get this x all alone, we're going to subtract 1 on both sides of the equation. So you're going to get x equals 2 minus 1 is 1. Looking at example 4, we have x plus 13 equals 21. And to get this x alone, we're going to subtract 13 by both sides. This 13's cancel, and we're left with x equals 21 minus 13 is 8. And that is our final answer. Looking at example 5, we have 7 plus x equals 7. So in this case, our 7 is positive, so we're going to subtract 7 on both sides. And then these 7 and this positive 7 and negative 7 cancel, and plus x is just positive x, so we're just left with x. And then 7 minus 7 cancels as well, so we're left with we're just left with x equals 0. And then here we have 16 plus x equals 15. So to get x alone, we're going to want to subtract 16 on both sides of the equation. These 16s cancel, and we're left with x equals 15 minus 16, which is negative 1. And now we are going to be looking at solving equations when we have division and multiplication involved. So if we have to think about this, what opposite operation do we have to use in this first example to get this x all alone or by itself? If you're thinking you want to divide by 3 on both sides of the equation, you are correct. So this 3 and 3 cancels out, and we're left with 1x equals 3 divided by 3 is 1, and 1x is the same as x, so x simply equals 1. Looking at example 2, we have negative 8 equals negative 4x. So to get x all alone in this equation, I encourage you to pause the video and try to solve for x in this one. And assuming you have given it a try, let's work through it. So to get x all alone, we're going to divide by -4 on both sides. So -8 divided by -4 gets you a +2. And then these two -4's cancel, and you're left with x. So x equals 2. And then in this third example, this one's a little bit more tricky. So we have 2 divided by z equals 1. To get z all on its own, what we're going to do is multiply by z, which these two z's cancel. However, right, what we do to one side of the equation, we must do to the other. So we're going to multiply both sides, and these z's cancel, and you're left with 2 equals 1 times z is the same as z, so you're left with 2 equals z. Looking at example 4, we have 10 divided by a equals 4. So we're going to do the same exact thing we did here. So we're going to multiply both sides by a to get this a out of the denominator. So these a's are going to cancel, and you're left with we're left with 10 equals 4a. However, in this case, we actually have an additional step because a isn't all on its own, which I do apologize. I meant to only do one step linear equations, but this is actually a 2-step linear equation. That's okay, because we can work through this. So to get a on its own, we're going to divide by 4. So these 4's cancel. We're left at a equals 10 divided by 4. And we can actually simplify this fraction 10/4 to 5/2. And that's our answer. Looking at example 5, we have 4 equals 1/4 times c. So what I would do is multiply both sides of this equation by 4. Because, right, what happens when we do that is that these 4's cancel, and we're left with 4 times 4, which is equals 16, and then we're left with 1 times c, which is c. So 16 equals c, or c equals 16 is our answer for this one. And then looking at example 6, to get this x variable, or this variable on its own, what we want to do is divide by this 3/4, because this 3/4 is being multiplied by the x. So we're going to say x equals 6/1, because 6/1 is the same thing as 6. And remember, when we divide a fraction, we're going to do the keep, change, flip rule, where the division changes to multiplication, and then we flip the fraction, so we get 4/3. And then here, we can cross-reduce because we can divide both 3 and 6 by 3. So 6 divided by 3 is 2, and 3 divided by 3 is 1. So you get 2 times 4, which is 8, and 1 times 1, which is 1. So you get 8 divided by 1, which is 8. So x equals 8.